Welcome back to our chemistry class. Today we can be discuss unit number 8, Physical and Chemical Equilibrium. It's a second volume book, Physical and Chemical Equilibrium. First, we have discussed about the chemical equilibrium. What is about the chemical equilibrium? Chemical equilibrium. Here, chemical equilibrium is a state in which the rate of the forward reaction is equal to the rate of the backward reaction. The rate of the forward reaction is equal to the rate of the backward reaction. Otherwise, backward na reverse reaction. Okay. What is about the rate of the forward reaction? Forward. What is about the rate of the reverse reaction? Backward. Let us consider one of the general reversible reaction. We know already, we learn about that, which one is the forward reaction and which one is the backward reaction, which one is the reversible reaction and which one is the that is irreversible reaction. Already we discussed. Oh, today we can be discuss one of the reversible reaction. Example, A plus B gives C plus D. Okay, A plus B gives C plus D. Here, A plus B is one of the forward reaction. We get C plus D, the product. And about C plus D are the product, it undergoes reverse, that is we get A plus B. Am I right? Here, initially, one of the reaction A and B are present. Am I right? Here initially, one of the reactant, that is A and B are present. Soon after, a few molecules of the product C and D are formed. So that is about the forward reaction. So A plus B gives C plus D. A plus B gives C plus D. This is a forward reaction. Am I right? The reaction proceed forward. The reaction proceed forward. That we are saying forward reaction. So another one, C plus D. Am I right? C plus D are the product. This also, we are saying the forward reaction. This come back, we get the reactant. C plus D come back, we get the reactant. That we are saying the reversible, it's a backward reaction. As the concentration of the product increases, here, as the concentration of the product increases, more products collide. Here, more products are collide, and then they react to the backward direction. As the rate of the reverse reaction increases, reverse reaction increases, the rate of the forward reaction decreases. Don't forget that. As the rate of the reverse reaction increases, the rate of the forward reaction is decreases. So we can be say that the rate of the both reactions become equal. Rate of the both reaction, maybe a forward reaction or maybe a backward reaction, becomes equal. We can be discuss one graph. I'm taking one graph here. Graph versus time. Time versus rate, reaction rate. Time versus reaction rate. I'm taking one graph. Here, first one, here, the rate of the reverse reaction is increases. The rate of the reverse reaction is increases, and also the rate of the forward reaction is also decreases. So it can be written as here equal rates. Okay, here first one is, here the rate of the forward reaction is decreasing. Am I right? The rate of the forward reaction is decreasing. The rate of the reverse reaction is increasing, but it is in equal rate. So we can be say the rate of the both reaction either may be a forward reaction or either may be a backward reaction becomes equal. Next one. Dynamic nature of equilibrium. Dynamic nature of equilibrium. dynamic nature of equilibrium. What is about the dynamic nature of equilibrium? Dynamic nature of equilibrium explain the forward and the reverse reaction. Dynamic nature of the equilibrium explain about the forward and the reverse reaction. It consists of forward reaction where the reactant react to form product. The reactant here, which are the, for example, the previous equation A plus B gives C plus D. I'm right here. One of the reactant here, A and B are the reactant, C and D are the product. A and B are the reactant, C and D are the product. Here, one of the reactant react to give product. And the reverse reaction, when this product, which are the product here, C and D are the product, this product can react to give back the original reactant. Okay, so reactant A plus B gives the product C plus D gives the reactant, original reactant. That we are saying dynamic nature of equilibrium. That is both reactant, forward and reaction, forward and backward reactions. That we are saying what? Dynamic nature of the equilibrium. Okay, here at equilibrium, what's the condition? At equilibrium now, both the forward and backward reactions are the same. Am I right? Product, forward reaction and the backward reaction are in the same rate that we are saying equilibrium. At equilibrium, the forward and the backward reactions are proceeding at the same rate. At equilibrium, the forward and backward reactions are proceeding at the same rate. There's no macroscopic change is observed. Am I right? There is no macroscopic change. Sometimes it may be a minute change, but here there is no macroscopic change is observed. So chemical equilibrium is a state of dynamic equilibrium. So chemical equilibrium is in a state of dynamic equilibrium. For example, how can I explain about that? Here, for example, I am taking two reactant. Here, two reactant example. H2 is one of the gaseous state. And also I am taking one more, another one, iodine. This is also gaseous state. Here, hydrogen and iodine are the reactant. Hydrogen and iodine, these are in a gaseous state. This one undergoes reacting, we get hydrogen iodide, HI. This is also gaseous, so you have to balance the equation. 2 hydrogen, so make it 2 here, 2 iodine. Now the equation is balanced. Okay, this is one of the equilibrium reaction. This is hydrogen gas. One of the hydrogen gas react with another one iodine gas. We get 2 moles of hydrogen iodide. Am I right? So next we can be discuss about homogeneous and heterogeneous equilibria. One of the very important question. Homogeneous and heterogeneous equilibria. Homogeneous and hetero. What is about the homogeneous? We know that homo means same. Am I right? Already I explained you. Homo means same and hetero means different. Don't forget that. Here, what is about the homogeneous? First we can discuss about the homogeneous. What is about the homogeneous? Here, homogeneous means all reactant and the product are in the same phase. Am I right? All reactant, for example, I wrote here one example. What is the example here? Hydrogen plus iodine. Am I right? This is also gaseous state. Iodine also gaseous state. Both two are the same phase. And also we get the product. Which one is the product? Hydrogen iodide is the product. This is also gaseous state. Am I right, yes or no? So hydrogen combines with iodine. Hydrogen gas is combines with iodine gas. We get hydrogen iodide gas. We have to balance the equation. 2 hydrogen, so make it 2 here. Now 2 iodine. Now the equation is balanced. In this equation, in this above equation, hydrogen is also gaseous phase, iodine is also gaseous phase, and also hydrogen iodide is also gaseous phase. So the reactant and the product, all the reactant, here having 2 reactant, one hydrogen and another one is an iodine, 2 reactants, that is a reactant and the product are in same phase, are in gaseous phase, am I right? One more example. I am taking one more example is methyl acetate. Methyl acetate. What is the formula for methyl acetate? Methyl formula CH3. Am I right? Methyl acetate. What is the formula? COOCH3. Methyl acetate. Already I explained that one. Am I right? How will you write the methyl acetate? Methyl acetic acid. What is the formula for acetic acid? Acetic acid CH3 COOH. Am I right? Acetic acid. This undergoes dissociation. We get H plus acetate CH3 COO minus. Am I right? Acetic acid. Acetate plus hydrogen ions. Am I right? Acetate. Okay. This acetate CH3 COO minus, we are adding methyl CH3. Now what is the formula? CH3 COO CH3. Am I right? CH3 COO CH3. This is what? Methyl acetate. This is an aqueous state. Aqueous and reacts with the reacts with the water, also H2O, aqueous state, both the forward and backward reaction, we get the product is acetic acid. So how will you get the acetic acid? Here water molecules, and this water molecules I am going to write HOH. Am I right? HOH. Yes or no? HOH. So can you say what is in this compound? This formula, what's the formula of this compound? CH3 COOH. Say all of you, CH3 COOH plus here CH3OH. Am I right? CH3OH. Okay. So how can you say the name of the compound? Acetic acid and methyl alcohol. Am I right? Can you say what is the IUPAC name of acetic acid? IUPAC name of acetic acid. Can you say? How much carbon is there? Having how much carbon? 2 carbon. 2 carbon means you have to say what? Eth. Am I right? Eth is the root word. Am I right? Already I said about that rules. Root word, and you have to say a single bond, double bond or triple bond. Now we have only single bond, so we have to say ANE, ethane. Am I right? So here the functional group is COOH. So we have to say oic acid. Am I right? Suffix, secondary suffix, oic acid. Already we discussed. So what is the name of the compound? Ethanoic acid. Ethanoic. E is dropped. Ethanoic acid. Next here. CH3OH. We know that one. Methyl alcohol. What is the name of the compound? This is a common name. Methyl alcohol. Am I right? How can you say the IUPAC name? How much carbon is there? 1 carbon. So first you have to say the root word of 1 carbon. Root word of 1 carbon. That is meth. Am I right? Meth. They have the single bond. So ANE. Am I right? So OH, the functional group is OH. So the suffix we have to add. For OH now, we have to add OL. Already we discussed. Okay, so what's the name of the compound? Methanol. Okay, this product, these two products, that is a ethanoic acid and methanol. These are also aqueous state. Aqueous state. So here, this equation also explain the reactant and the product. The reactant and the product are in same phase. Am I right? Not in different phase. These are all in, that is a reactant, methyl acetate, water, and also ethanoic acid, and also methyl alcohol. Everything are in same phase, aqueous state. What is about the aqueous? Aqueous means must contain water. Containing water. That we are saying aqueous state. Am I right? Water state. Okay. So these two equations are the homogeneous equilibrium. Homogeneous means that all the reactant and the product, all the reactants and the products are in the same phase. Same phase is about the homogeneous. Don't forget that homo means same phase. What is about the heterogeneous? Don't forget that heterogeneous. Heterogeneous means the reactant, all the reactant and the product, we can be say in different phase. Am I right? if the reactant and the product of the reaction in equilibrium are in the different phase. Different means hetero, same means homo, different phase. Okay, we can be explain one of the example. Water. What is the formula for water? H2O. Am I right? We all of you know that one. Water is a liquid state. Am I right? Liquid state. Under course, we are writing one of the equilibrium, both forward and backward reaction. Next, again water is converted into again water, H2O. This water is a gaseous state. Am I right? Gaseous phase. Here water, first water is a liquid. Next it become a gaseous form. Am I right? So here the reactant and the product are in different phase. The reactant and the product are in different phase. That we are saying heterogeneous. Try to learn the equation. Equation is very, very important. Without equation, there is no chemistry. So try to learn the equation is correctly. Okay. Next, I am taking another one more example is calcium carbonate. Calcium carbonate. What is the formula for calcium carbonate? So don't worry about that. Calcium is, all of you know that one, Ca. Calcium. Calcium carbonate, CO3. Am I right? Calcium carbonate. Which are the elements present in calcium carbonate? Calcium, carbon and oxygen. Am I right? So 3 elements, calcium carbonate. This is in a solid state. Don't forget that calcium carbonate is a solid state. And both forward and backward reaction we get. This calcium combines with one of the calcium, combines with one oxygen. One of the calcium combines with one oxygen. We get calcium oxide. What's the formula? CaO. This is also a gas. This is also in a solid state. Calcium oxide is a solid state. And also here one is another one gas is that is called carbon dioxide, CO2. Right? This is a gaseous state. Don't forget that. Right? So calcium carbonate formula. What is the formula for calcium carbonate? CaCO3. Okay. This undergoes can be say decomposition like that. We can be decomposed. We get calcium oxide and carbon dioxide. Calcium oxide is a solid state. Don't forget that. Solid state. Calcium carbonate is also solid state. But in the carbon dioxide is a gaseous state. Am I right? Gaseous phase. We can be say gaseous phase. So here, what is the definition of a heterogeneous equilibrium? Here, if the reactant and the product of a reaction in equilibrium are in the different phase, then it is called as the heterogeneous equilibrium. Very, 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 very important question. Try to understand the concept. Next we can be discuss law of mass action. What is about the law of mass action? Okay. What is about the law of mass action? In 1864, two chemists, Max Millan and also Peter Weiss, two chemists formulated the law of mass action. Okay, law of mass. What is that law? He formulated one law. This is called the law of mass action. What is that? The law. At any instant, the rate of a chemical reaction at a given temperature is directly proportional to the product of the active mass of the reactant at that instant. At any instant, the rate of the chemical reaction, don't forget that the definition very, very important. At any instant, the rate of chemical reaction at a given temperature is directly proportional to the product of the active masses of the reactant at that instant. At any instant, the rate of a chemical reaction at a given temperature is directly proportional to the product of the active mass of the reactant at that instant. This is the laws of mass action law. Don't forget that. I am writing one expression that is rate is directly proportional to reactant. What is that one? Rate is directly proportional to the reactant. Don't forget to make here one square bracket. Okay, one of the square bracket. After the square bracket, we have to write X. Okay, after the square bracket, we have to write X. Rate is directly proportional to reactant X. This is what? Law of mass action. What is law of mass action? Rate is directly proportional to reactant X. What is the one of the law of mass action law? What is that one law? At any instant, the rate of the chemical reaction at a given temperature is directly proportional to the product of the active masses of the reactant at that instant. Here, what is about this X? Don't forget that you have to write the X. X is the stoichiometric coefficient. X is the stoichiometric coefficient of the reactant. X is what? Stoichiometric coefficient of the reactant. And about here having one bracket, square bracket. This square bracket represents the active mass of the reactant. That we are saying the concentration, like that we can be say the concentration. Okay, the square bracket represents the active mass of the reactant. That is concentration. How to write one formula for active mass? Active mass is equal to N divided by V. Okay, N divided by V, mole dm raised to minus 3 or mole liter minus 1. Okay, this is about the formula, number of moles divided by volume V. Okay, don't forget that. Here, don't forget what is N here. N is the number of moles. What is N here? N is the number of moles and V is the volume of the container. Okay, volume of the container. Next we can be discuss one of the very important 3-mark question, one of the very important question. Please, my dear children, try to learn this question thoroughly. Equilibrium constant Kp and Kc. Equilibrium constant, one of the very important question. Equilibrium constant Kp and Kc. Okay, equilibrium constant Kp and Kc. We can be consider one of the reversible reaction. We can be consider one of the reversible reaction. What is about the reversible reaction? Reversible reaction means both the forward and backward reaction. Am I right? Both the forward and backward reaction. Let us consider X moles of A plus Y moles of B gives L moles of C and M moles of D. Am I right? X moles of A plus Y moles of B gives L moles of C and M moles of D. Here, A and B are the reactant. Don't forget that here. A and B are the reactant. C and D are the products. Am I right? Here, what is A and B? A and B are the reactant and C and D are the product. Here, what is about the X? What is about the Y? And what is about the L? And what is about the M? These are the stoichiometric coefficients of A, B, C and D. Am I right? These are the stoichiometric coefficient. Okay, anyhow, here we have to apply the law of mass action. What is about the law of mass action? What is about the law of mass action? That is, we can be write the rate of the forward reaction. What is about the rate of the forward reaction? Just we are applying what is about the rate of the forward reaction. That is rate of the forward. That is RF. Am I right? Rate. What is RF denotes? Rate of the forward reaction is directly proportional to reactant. Which are the reactant here? A. As per this equation, the reactant is A and the product is B. Am I right? You have to write on square bracket. Am I right? Square bracket. Square bracket denotes the active mass, am I right? So in the square bracket we have to write the coefficient. Here x is the coefficient of A, am I right? So we have to write the x is the coefficient of A and y is the coefficient of B, right? Am I right? So Rf is directly proportional to active mass of A power x, active mass of B power y, am I right? So next one, we have to write Rf is equal to Kf. Okay, Rf is equal to Kf. And we have write active mass of A power x, active mass of B power y. Rf is equal to Kf, active mass of A power x and active mass of B power y. Am I right? Here what is Kf? Kf is called proportionality constant. Proportionality constant. Okay, this is for forward reaction. Okay, we try to learn this equation. That is, what is the equation? X, that is x moles of A plus y moles of B gives L moles of C plus M moles of T. Here the rate of the forward reaction is over. What is about the rate of the backward reaction? Similarly, we can be written as the rate of the backward reaction. Backward means RB, reverse reaction. Okay, backward reaction. RB is directly proportional to product. Which is the product? Which are the product here? C, active mass of C and active mass of D. Which are the coefficient? C means L is the coefficient of C and M is the coefficient of D. Am I right? So we can written as R. RB, rate of the backward reaction, is equal to KB. RB is equal to KB, then active mass of C power L, active mass of T power M. Am I right? Here, I told that what is about the KB? KB is called a proportionality constant. Rate of the forward reaction, KF. Rate of the forward reaction, Kf is the proportionality constant. Rate of the backward reaction, Kb is also proportionality constant. My dear children, at equilibrium, both the forward and backward reaction will be equal. Am I right? So we can be written as at equilibrium, Rf is equal to Rb. Okay, that is rate of the forward reaction will be equal to rate of the backward reaction. Rate of the forward reaction will be equal to rate of the backward reaction. Am I right? So we can be written as rate of the forward reaction. What is about the rate of the forward reaction? Ref. Am I right? Rate of the forward reaction is equal to Ref. That is equal to rate of the backward reaction, Rb. Am I right? So we write that Kf, that is a proportionality constant, Kf A power x, active mass of A power x, active mass of B power y, that is equal to proportionality constant Kb, active mass of C power L, active mass of D power M. Am I right? So we can be written as, from here we can be taken as R Kf by Kb. Am I right? Kf by Kb is equal to C power L, D power M, A power x, B power y. Am I right? Kf by Kb is equal to C power L, D power M divided by A power x, B power y. Here, this term that is about C power L, D power M, A power x, B power y, we can be written as Kc. What is about the Kc? Kc is an equilibrium constant. Don't forget that. What is about the Kc? Kc is an equilibrium constant. Kc is an equilibrium constant. Okay, in terms of concentration, that is an active mass. Like that, we can be write the Kp also. Okay, what is about the Kp? If the reactant and the product of the above reactions are everything in gaseous phase, suppose these are everything in a gaseous phase, we can be written as, the equilibrium constant can be written as in terms of partial pressure. Partial pressure means Kp. What is Kc? Kc is an equilibrium constant. Kc is an equilibrium constant. Kp is the partial pressure. I will ask the question. Don't forget that. Okay. Kc, what is about the Kc? Kc is an equilibrium constant and Kp is the partial pressure. So Kp can be written as Kp is equal to P C the power L into P D power M divided by P A power X into P B power Y. Here, what is about the PC, PD, PA, PB? These are all what? Partial pressure of gas A, B, C and D. Don't forget that. PA means partial pressure of PA, partial pressure of PB, partial pressure of PC, partial pressure of PD. These are all what? They are the partial pressure of A, B, C and D. Am I right? Okay. Next, a small one question about the equilibrium constant. I think that please take that page number 6, all of you. There have one small definition for equilibrium constant. Okay. It's a very, very important question. What is about the equilibrium constant? At a given temperature, the ratio of the product of active mass of the reaction product raised to the respective stoichiometric coefficient in a balanced chemical equation to that of reactant is a constant known as equilibrium constant. It's one of the 2-mark question. Try to learn about that definition. Okay. So today we discuss about that page number 4, chemical equilibrium. What is about the chemical equilibrium, dynamic nature of equilibrium, what is a homogeneous and what is a heterogeneous equilibria, and about the law of mass action, especially for one of the very important question, equilibrium constant, Kp and Kc. These are all important questions. Try to learn this all the question. Okay. Thank you all of you. Thank you. Have a nice day.